pre-algebra.
I know, because I was doing it during memory.
Lessons. And I say lessons because there's actually two of them in here. 6-5 and 6-6. And this is actually probably the last lesson you're going to have for this chapter. And then we're going to move into chapter 7. So what we're looking at today is we're looking at solving inequalities, not just graphing them. We already went through the graphing yesterday. If we look back here, we see the 4 different scenarios you can run into if you're graphing an inequality. Okay, and these notes are up online already. What we're going to be looking at today more specifically is solving inequalities, which means just like solving equations, we're focused on isolating the variable. So I'll give you an example. Let's say that we have a bank account, we'll call A, and in that bank account we have money withdrawn, about $7 worth, okay? However, we need to maintain a minimum balance of $10, okay? So it can be greater than or equal to $10 in order to keep what we call free checking so that we don't incur any fees. All right, so the question is, how much money do I have to have in my account so that I can have $7 withdrawn but still maintain a balance that gives me free checking? And so this is what a scenario like that would look like. Now, how do I go about solving this? What would I do? Liam?
I think you would add 7 to the 7.
Okay.
Add 7 to 10, which
Right.
is 17, and you have A, and then the greater than underline thing to the 10, and then A has to be greater than 10, so full circle over 10 going.
Hold on, so you're graphing it. Hang on 1 second.
Right.
Liam, that is correct.
One of those two.
You carry down the A, okay? You carry down the symbol. You add the 7 to the 10, and you get A is greater than or equal to 17. If I were to graph this, okay, if I were to graph it, just draw a little number line here in the margin, okay? I put 0, I put 17, and I would put a circle, filled in circle above the 17. And which way is my arrow going? To the right.
What the heck?
Okay? All right, so that's very good. How many of you feel comfortable with the adding, subtracting portion of things? Okay. Okay. Let's look at it. Let's look at another scenario here, real quick, just because I feel like it might be useful to us. Let's say that we have let's say we have t, and we are adding 17, but that has to be less than 24. Okay, what would I do in this particular situation? Casey?
Subtract 17.
Okay, I'm going to subtract 17 from both sides. Very good. And I see that the 17s go away on the left. And so t is going to be less than what? 24 minus 17 is what?
4. You already know.
I do.
It's 4.
It's
4.
7.
Thank you. It's 7. 17 plus 3 gets you to 20. Add 4 more, 24. 3 plus 4 is 7. So it's 7. Like so.
Wait, on the last thing you just did, for the graph, where to go? Right or left?
Right. Because A has to be greater than 17. Okay. Getting into new material today. We're going to look at 4 situations. Okay, and I'm going to kind of break down these 4 situations. These particular examples are incredibly important. So I'm going to ask that you write these down exactly as I write them down on the board. Okay? All right, the first example I'm going to do is going to be x over 3 is greater than 4. Okay? And in this particular example, I'm going to go ahead and solve each one kind of in the center of the screen. And so I'll zoom in here a little bit and kind of break this down. You're going to solve this just like you would a normal equation. Okay? We want to isolate the variable x. I have to do the opposite operation. Which operation is that? What am I going to do? Kennedy? Yeah, I'm going to do multiplication. Okay, so for this first one, I'll just walk through it. Because we're dividing by 3, we have to multiply by 3. When I'm multiplying fractions, I like to set it up so that the one number is over 1. I can then see the cross simplification that's got to happen here with the 3 in the top and the 3 in the bottom. And I can cross them out. Okay, which, there it is. Now, the next step then is to do the same thing on the other side. Because there's no fraction over there, I can just write multiplied by 3. I'm actually doing the same thing to both sides, even though it looks just a tad bit different. And so on the left-hand side, I'm left with x. I carry down the symbol, and then 4 times 3 is what, Isaiah? 12. Okay, so that's pretty straightforward. That's not mathematically so different than what you have been doing in regular equation solving. It's not even a two-step, okay? So there's that. Any questions about this one? Okay, let me go ahead then and go on to the next one. The next one is going to be just as simple. We're going to go ahead, except that this time it's going to be 10a is less than 31. Okay, so I zoom in on this. What am I going to do here? Yeah, Dylan. Okay, I'm going to divide 10 on both sides, right? I want to isolate that a. Now, 10 over 10 really becomes 1. So it's not like it's going away. We're just changing it into a number that we don't have to show. It's kind of like it's going behind the scenes. So 10 over 10 becomes 1. So we have 1a, but we don't have to write the 1. So is a. And that's going to be, again, carry down that symbol. 31 divided by 10. Move the decimal one place. 3.1. Yeah, Liam.
Why don't we write the 1? Like, would it really matter?
If we put a 1a here?
Would that just be like the same thing?
Yeah, it's not, we just don't typically write ones. And we probably should. It's easier for us to comprehend it in our head.
So
But
if we did on the homework,
that would be totally fine.
Right.
Yeah, and it might even help you in the future as problems become more complicated. Very good. Just make sure when you write your ones that you write them so they look exactly like ones. Yep, definitely cool beans. All right. Now, that probably didn't seem too very difficult, but now we're going to look at 2 scenarios that are similar but a little trickier. Yes? Someone? Okay. Let's say I have y, and I'm going to divide it by -2, and I'm going to make that greater than or equal to 7. Okay? Let me zoom in on this. Let me walk through this. I know you guys know how to solve it, but there's a trick in here that you wouldn't necessarily know right off the bat. Okay? First of all, before we even solve it, can someone give me a number that would make this statement true? Can someone give me a number that would make this statement true? What could you put in place of y so that this statement is a true statement? Reese? -14 would be a good choice. Yep. And then let's look at that for just a second. If I had -14 over -2, okay, greater than or equal to 7, that becomes 7 is greater than or equal to 7, and that's true because it can be equal. Okay, so this is a true statement. Check. All right, so we know that just looking at it right off the bat, -14 has to be a solution to this problem. I want you to keep that in the back of your head for just a moment. Now let's go through and solve it like we didn't know what the answer was. Okay, so I'm going to go ahead and do this. And you would start by multiplying both sides by -2. Okay, and we would see that because of those -2's, we can cross simplify like that. Then we would go ahead and carry down the y. And if I carried down the symbol exactly as it's written, and then do the 7 times -2, it's -14. Okay, and, oh shoot. That's not supposed to happen.
Sorry. Well, what was supposed to happen?
When you multiply or divide by a negative, you're supposed to flip the sign.
Multiplying by
Right, so, well, let me do this. The original symbol is that. When you are multiplying or dividing by a negative, you need to flip the sign. So negative 14 is not a very good example because it's the one anomaly that works here. Though it's a good number, it worked in the original problem. Okay, so just note that we're supposed to flip here. Okay, you're supposed to flip the sign. Only when you're multiplying and dividing by a negative. That's just, well, that's what I was trying to show and I so poorly showed.
Did it flabbergast you?
No, I'm not getting angry. Let's do this.
I laugh when I'm angry.
What is the word coming?
Look at him, he's angry.
No.
Got him, he's angry.
Shh. Landon Smith, would you agree that negative 16 could have been a solution to the original problem?
Yeah.
Landon, plug it in. Walk me through it right now. Walk it through for the whole class. I plug a negative 16 in here. Okay, so then what's it become? No, 16 divided by 2 is what? Casey, I really don't need any more confusion because I already picked a bad example. Landon, 16 divided by 2.
16 divided by 2.
Okay, so this side becomes a positive 8. Is positive 8 larger than 7?
Yes.
It is. Now, negative 16 is then a solution to the original problem, right, Christine? It is. If I had not flipped the sign, and I plugged a negative 16 in here, I know it's a solution to the original problem. I've tested it. It wouldn't work. Negative 16 is not equal to negative 14, and it's not larger than negative 14. So what, as mathematicians have decided, as a rule to solving these, is that when you multiply or divide by a negative, only a negative, that you have to flip the sign to maintain the value of the inequality. So in this particular situation, we would flip it. So you would, because I multiplied by a negative 2, the sign flips. And now, negative 16 is a possible solution because it's less than negative 14. Negative 14 was not a good example right off the get-go. Let's look at, we need to look at probably 2 more of these just to get it down. So let's go ahead and flip over here to a new one. Let's do this. Negative 6x is greater than 3. Okay, if you were to solve this normally, let's do this in green. You would divide both sides by a negative 6. Okay? So you divide by a negative 6, you divide by a negative 6, and you get x is less than a negative 1/2. Why did I flip the sign? Yeah, Casey.
Because you're dividing by a negative number.
Because I'm dividing by a negative 6. Okay? I'm dividing by a negative 6. So I had to flip the sign.
So that's all you gotta do.
That's all I got to do when I'm dividing or multiplying by a negative number. Flip the sign. All right, so let's come up with an answer that would be true in this particular situation. If I multiplied negative 6 by 1, would this statement have been true? Negative 6 times 1 would have been negative 6 greater than 3. Is that true?
Yeah. No.
You guys are just blindly saying yes or no. Think about it. Negative 6, is that larger than 3?
No.
No. Negative 6 is way down below 0. However, if x was negative 1, it's true. If x was negative 1, and I multiplied these two, ladies and gentlemen, guys.
Yes, it would be like.
Hey, guys. I'm doing a lot of talking over people. Not particularly happy about it. If x was negative 1, you'd have a positive 6 here because you'd have a negative times a negative. And Isaiah, you're right. It would work. Does a negative 1 work here? Is negative 1 less than negative 1/2? It is. Negative 1 is further away from 0 than negative 1/2 is. So you see by flipping the sign, we are able to maintain the value of the inequality. If you didn't flip the sign, it would be wrong. Okay, so you have to flip the sign when you're multiplying or dividing by a negative. Okay, one more example. Liam's going to walk us through it.
Oh yeah.
Oh no, is what I would say. Go ahead.
Yeah.
R divided by -3 is greater than 10.
Okay.
Okay, Liam, what are we going to do?
On the left side of the R over -3, you put a little dot.
Okay, I'm going to put a little dot.
And then,
Any particular color choice?
rainbow.
Okay, rainbow.
Oh, that shows his
I'm a little out of rainbow
personality.
options.
Teal.
Teal.
How about that?
Okay, I can probably do teal. Hang on one second.
Magenta.
Magenta.
Is that your final answer?
Perfect. And then draw a line and magenta also. And then a -3 above that line. And then an R. No. A 1. Thank you.
Hey guys, relax back there, all right?
You were
It's a little
the
stress.
party, Jesus.
Guys, all right. Oh, get back to it. Liam.
And then,
Everyone could smell it. Everyone.
No, that wasn't me then.
Oh.
and then, yeah, that. And then you do that.
He's like,
10 times -3. Positive times a negative is a negative, right?
Yes.
So -30.
Daddy.
Hey guys.
-30. R is switch the sign.
Okay.
We're working with a negative. And there you go.
Yes, Liam.